So hello everyone. Today we will tackle about finding the sides of a triangle and its area. So there are different kinds of triangles, but first we will talk about the right triangle. So what is a right triangle? A right triangle is a triangle that has an angle of 90 degrees. So we will make a right triangle. This is angle A. Wait, hang on, wrong. This is angle A, this is angle B, and angle C. And this is your right angle, which is 90 degrees. Always remember that the opposite side of your right angle will always be your hypotenuse, or the longest side. So this here is side C, and then the opposite of angle A is side A, and then side B over here. Now, we can use Pythagorean theorem for right triangles. So, we have a squared plus b squared is equal to c squared. We can also use SOHCAHTOA. So, and then KAHTOA. Wherein is sine is equal to the opposite over the hypotenuse. And then cosine is equal to the adjacent over the hypotenuse. And lastly, TOA, tangent or tan, is equal to the opposite over the adjacent. So, which one is the opposite, the adjacent, and the hypotenuse? Again, when you have a right triangle, the hypotenuse is always the side opposite to the right angle or the 90 degree. While for the opposite and adjacent, it depends where your angle is. So let's say your angle is over here. You are given an angle, a specific angle on angle B. Therefore, your opposite will be side B and your adjacent will be side A. And if your angle is on angle A, therefore your opposite is on side A while your adjacent is on side B. And C remains your hypotenuse. So let's move on. Let's say that side A is equal to 5 while side B is equal to 8. And we are looking for side C. This shall be named X instead. So we can now use the Pythagorean, which is a squared plus b squared is b squared is equal to c squared, where a is 5 squared plus 8 squared is equal to x squared. So 5 squared is 25 and 8 squared is 64. So 64 plus 25 is equal to 164, 25. It's equal to 89. Is equal to x squared. Since we are only looking for the x, we will find the square root of both sides so that we can cancel the squared. So this is x. And square root of 89 is 9.43. 9.43. Let's clear the point. 43. Therefore, your c or your x is 9.43. Next. So let's say we have triangle ABC. We have A here, B, and C. Let's say A is equal to 5 and B is equal to 4. And we will be looking for our C, which is x. So using the Pythagorean theorem, a squared plus b squared equals c squared, we will find our C. So a squared, that's 5 squared, plus 4 squared is equal to x squared. So 5 is 25 plus 16 is equal to x squared. So this is 25 plus 16 is 31, I think. So 25 plus 16 is 41 is equal to x squared. Now since we are only looking for x or c, we have to find the square root of both sides. So square root of 41 is equal to 6.4. So therefore, x is equal to 6.4 or 6.40. So your c or your hypotenuse is 6.40. Now let's try another example wherein c is 5, b is, we will be looking for b, so b is x and a is equal to 3. It's equal to 3. So do the Pythagorean formula. So a squared b squared is equal to c squared. So we have a, which is 3 squared, and b for x squared is equal to 5 squared. 3 is 9 plus x squared, and 5 squared is 25. Combine like terms, so x squared, move 9 to the other side and it will become negative. So 25 minus 9. 25 minus 9 is equal to 16. So x squared is equal to 16. Since we are only looking for an x, we find the square root of both sides. So x is equal to 4. So therefore, your side B or your height is equal to 4. Hang on. Now this time we will use SOHCAHTOA. Let's say angle A is 20 degrees and C is 10. Now we will look for A, side A, also known as your height or your opposite. So since this is the angle, then side A will be your opposite and side B will be your adjacent. Side C will always remain as your hypotenuse. So A will be x since we are looking for it. Since your opposite and your hypotenuse is present, then we can use SOH. So SOH is sine is equal to opposite over the hypotenuse. So this will be sine 20, 20 degree, 20 degree is equal to the opposite, which is x over 10. You cross multiply, so this will become 10 sine 20 is equal to x. So put this in your calculator, 10 sine 20, and you should have 3.42. 3.42. That will be your x, or your side A. Let's try another one. Let's use the same triangle. What if we are to look for the adjacent, or the B? So since our adjacent is present, as well as our hypotenuse, so we can use CAH, or cosine is equal to the adjacent over the hypotenuse. Now, cos 20, since it's 20 degrees, is equal to the adjacent, which is x, over the hypotenuse, 10. So, cross multiply, this will become 10 cos 20 degree. So 10 cos 20, 10 cos 20 is equal to, so your x is equal to 9.40, since we have to round off. So 9.40. Let's try another one. Clear this one up. Now let's say we are looking for B, and the opposite side is given. So we can use TOA, or tangent is equal to the opposite over the adjacent. Since our opposite is present, so we have tan 20 is equal to the opposite, 7 over x. Cross multiply, this will be tan 20x is equal to 7. Divide both sides by tan 20, so that x will be the only thing remaining on the other side. So tan 20 will be cancelled. So x is equal to 7 over tan 20 is 19.23. 19.23. Therefore, your adjacent, or your base, is 19.23. Now this time, we will be looking for the angle. What if you were given side A as 2 and 3 in side C? And we will be looking for our angle A. This is our opposite. Side A is our opposite, while side C is our hypotenuse. So we can use sine, sine x is equal to the opposite, which is 2 over the hypotenuse, 3. All you have to do is shift sign in your calculator. So this will be x, and this will become sine -1 times 2 over 3. So let's do that. Shift sign 2/3. Therefore, your angle A is equal to 41.81 degrees. And that's it. So you can use this way. It just depends on which side is present. And you will be able to get the missing pieces. So let's move on into finding the area of a right triangle. So here, in looking for the area of this right triangle, we just simply have to multiply 1/2 times the base and the height. So we all know that A is the base and B is our height. So let's say A is equal to 2 and B is equal to 5. Then we have to put it here. So A is equal to 1/2. Base is 2 times the height 5, then that's 10. Oops, wrong. Times 5, that will be 10. So A is equal to 1/2 times 10. So that will be 5. So the area of this triangle is 5 meters squared, or squared meter. So suppose that we have no B, or we have no height, but we have a C. So to look for our height, we will use the Pythagorean theorem, wherein, again, a squared plus b squared is equal to, it's equal to c squared. So your a is 10, that's squared, b is 15 squared, and, sorry, my bad, that's wrong. This is x squared, and your c is 15 squared. So 10 times 10 is 100. This is x squared. 15 times 15 is equal to 225. 225. So combine like terms, move the 100 to the other side, it will become negative. So we have 225 minus 100. So that will be x squared is equal to 125. Since we are only looking for x, we will square root it. So the square root of 125 is 11.18. Or if you want a radical, then you have 5 square root of 5. So since b is 11.18, let's delete this. So since b is 11.18, 11.18 or 5 square root of 5, then we can remove this. Now we have the height, so we can proceed on to the formula for the area, which is area is equal to 1/2 base times height. So area is 1/2. The base, or the A, is 10 times the height, 11.18. Then you have, type it in your calculator. So 1/2 times 10 times 11.18. So we have 55.9. So the area is 55.9. If there is a unit given, meter or centimeter, you have to put a square in it. So like meter squared or squared meter or centimeter squared. It depends on the given unit. So moving on. So let's try this problem. A company must stretch a cable from the top of the tower that is 25 meters high to a point 50 meters away from the base of the tower. So let's make a tower. And then so it is said that the tower is 25 meters high. So let's make this red. So from here, this point to this height. Okay. To this, that is 25 meter. So 25. And then 50 meters away, high to a point 50 meters away from the base of the tower. So 50 meters away. So let's do this one again. So from here to here. And then this is 50 meters. 50 meters. And then they're gonna stretch a cable from the top of the tower to the point 50 meters away from the base of the tower. So from here to here. So now we have a right triangle. So since the height is 25 and we have a base of 50, we are looking for the hypotenuse. So we will simply use just SOHCAHTOA. So I mean Pythagorean theorem. So I am sorry, my mistake. So a squared plus b squared is equal to c squared. So let's say this is a, b, and c. This is c, this is a, this is, and this is b. So a is 50 squared plus 25 squared is equal to c squared. So 50 squared is 2500. So 2500 plus 25 squared is 625. 625 is equal to c squared. Then add both. 2500 plus 625 is equal to 3125. Then you find, since we are only looking for c, you will find the square root of both sides. So square root of 3125 is, so c is equal to 25 square root of 5 square root of 5, or 55.90. 50.90 meters. So that's your C. So now let's try this question. Wait, I forgot something. So, a mathematically inclined squirrel sits atop a 14-foot tall tree. He spies a nut on the ground some distance away. After careful measurements, he determines that the nut is 74 degrees from the base of the tree. So how far is the nut from the base of the tree? So I'm sorry, I had to fix that. So let's continue. So the height of the tree is 14 foot. So let's say 14 foot. Oops. Go. Let's say 14 foot. 50. And then the angle from the squirrel is 74 degrees. 74 degrees from the base of his tree. So how far away is the nut from the base of the tree? So we can we're looking for the distance, but we can't find that yet since we're missing one side. So now we will use SOHCAHTOA for this. So let's say we are looking for our hypotenuse instead. Let's look for this side first. So our hypotenuse and our adjacent is present. This is our adjacent, 14 feet, since the angle is over here and its opposite side is this side, or the distance from the base of the tree to the nut. Let's say this is A, B, and then C. This is C, this is A, and this is B. So now we will look for our C, or our hypotenuse. So our hypotenuse is present as well as our adjacent. So what will we use? We can use Ka in SOHCAHTOA. We can use Ka, wherein cos is equal to adjacent over the hypotenuse. So cos 74 is equal to the adjacent, which is 14 over x. So that's cos 74x is equal to 14. Then we divide both sides by cos 74. So this will cancel. Therefore, x is 14 cos 74 is equal to 50.79. 50.79. So your hypotenuse is 50.79 feet. Now let's look for our distance using the Pythagorean theorem. So now we have the value for B and C, so we can go ahead and use the Pythagorean theorem. A is x squared. Let's remove this. Wait. Let's use y for A instead. So this is y squared plus B, which is 14 feet. So 14 squared plus, equals to 50.79 squared. So we have y squared is plus 14 squared is 196 is equal to 50.79 squared 2579 2579.6 minus 6 to 41. Then we move this to the other side. 196 will become negative 196. So y squared is equal to 251 25789.0241 minus 196. That's minus 196 is equal to y squared is equal to 232,383.6241 624 and 1. Then we square root both sides, so we can only find our y or a. So square root of 2383.6241 is 48.82 meter. So therefore that's our distance or our a, and that is how far away the nut is from the tree. So that ends our topic. Thank you.